زي جاي عندنا بالتمرين يعني واحد يوم صراحة ما ضبطيش.
يعني يوم الأربعاء كويسة ونعملها؟
لا ما هو الفكرة هو نغير الماتيريال. نغير تكون يعني صراحة ما نسوي إذا سويت الأربعاء
نعمل كويز على المشاء دارسينها. استفدنا من الموضوع.
أو نأجل أسبوع إذا ممكن.
طيب ماشي كده شوي هلا نشوف. دخل الصورة طيب بالموضوع.
والله كل شيء
وبعدين
شكل الصورة اليوم.
I don't know. السلام عليكم. About the quiz. About the quiz. So, yeah, the issue is that we need to do more quizzes until the end of the semester, okay? And we have only done one, or you postponed one before the break, okay? So we have to do more, okay? Why you have to do more? This is for your benefit. I know it's much better in the يكون weight for each quiz to be 3 points rather than 5 points. So if you don't do well, it's not that much. This is why I thought about making a quiz next week. If you don't do it next week, we will do it. This is still the second, okay? For the third, or fourth, or fifth. Usually, whenever you start the midterm, okay, the first midterm, خلاص, your time is all the time busy. So I don't know. I can have give some flexibility instead of Monday, Wednesday. Because يعني the week after maybe we'll have another one.
لا بس Monday أحسن. Monday.
Okay, so let's vote. I'm open to open solution. Okay, who goes for Monday? Wednesday. That's okay. So we will stick to Monday. Good. So it will be two lectures. Okay. So the one that is recorded and today, I think they are easy or easy to go through. Okay. What else? Midterm exam. I will grade it, or at least I have it in my schedule to be on Wednesday night. Okay. So Thursday, I think your grades will be on the blackboard. I hope. If not, during the weekend. What else? What else? Because I will be posting another homework 2 soon. Homework 1 grades have been posted or not yet? No. طب at least the key was posted. طب كويس. I will talk to Amif again. Okay, he is in charge of correcting. Why you're late, Hisham? Oh, go on. I don't care. 1 second, it's late. Uh-huh. So I posted some slides on the Blackboard. Personally, I think, or I was against slides. Well, unless it is a heavy mathematical course like electromagnetics or probability. Okay. Other than that, I think it is better to just write so that you are following the material. Okay, but yeah, I'm just trying and making trial and error. Okay, so I thought that maybe this topic is suitable to explain, and I will explain a lot. Okay, on the slides. So I will see. Okay, how you perform. Then the next one, maybe I will go back to normal whiteboard, or I will keep with slides. Good. So I will be collecting even your feedback. Okay, what's your opinion? So multiplexing techniques. What is this? Question before you start? No. So you remember the chain. So we have, whenever we have a signal that is analog, it first comes to the sampler, then the source encoder, then the channel encoder, then the modulator, and then here the multiplexer before the RF and the signal to fly. Good. So the multiplexer, this is the topic for today. Well, to continue here, there is a channel that is covered in the recorded lecture, and at the receiver side, everything the reverse. Okay, so multiplexer and the multiplexer. Definitely, we will explain the multiplexer and the demultiplexer together. Okay, so these two, I will explain them. Good. This is the topic for this chapter. First of all, what is the meaning of multiplexer? Multi, several means. Okay, so here, this is to make multiple users access. What does that mean? So what is the router here? How can we access more than one user at the same time to the router? How can you at home download some content while your brother is also connected, while your father is sending whatever? Okay, so how several users can access at the same time? This is the idea. Even if it is a router or it is a tower by Ooredoo Vodafone. Okay, how can we make several users to access? Okay, it is very important. Otherwise, the system will not be commercial. Okay, Ooredoo or Vodafone, they will not set up a network only for you. Okay, so it has to be to many customers. Okay, in order to make it logical. Okay, so the idea of multiple user is a must. Good. I made here this slide. Yeah, it will be tough this month. So this slide just to show you a base station. Okay, I think that you also have seen a base station, but yeah, in case. So this is a base station next to our mall. So here you see this is the base station with this height. This is a 32-meter height base station. Okay, it is, you see here. So you see the trailer. With the wheels and so on. So it is fully functional. Okay, they can bring here a small one, okay, to carry it, and it will move. And here these parts, they can be folded down and all of them put inside the trailer. Okay, and it moves. This is why they call this one to be, it's called cell on wheels. Okay, or they call it the cow. So the engineers, where is the cow? The cow is here, the cow is there, and so on. Okay, here, so it is moving. You see here, it is an empty space. So yeah, it can move. Okay, so maybe next year you will go and it is not there. Okay, officially, these kind of base stations are whenever you need them for a specific event. Okay, so there is a football match. You next to the football, you expect a lot of people. Okay, so you will put a base station. But other time, okay, they will put it there for years. If it's working fine, so here the area, maybe there is no high-rise building. Okay, so they find it suitable to leave it there. Especially if the landlord, okay, has no idea what's happening, so they will leave it there. Good. So there are some cows here that I saw in Doha. I don't know, 7-8 years they are there. Good. So yeah, but it is another approach. So I thought it is suitable. So multiple access. How can we make users to enter at the same time? We can make them to enter at the same time through these approaches. So here, reserved not for one single user. Okay, we cannot have a system only for one user. So how to make users to enter, okay, or to be at the same time going there. Even we multiplex them in terms of time, frequency, code, or space, or a mix up between them. Good. I will be going through each one of them separately to see how they work, what is the advantage, disadvantage, okay, and where have been used. Cool. So I start with the first one, frequency division. This is the most intuitive, okay? This is the one that has been used in 1G, but there is an upgraded version that is in 4G and 5G. So yeah, it is old, but it has been adapted to be reused, okay, in 4G and 5G. Good. So what is the idea? Here, trivial. So Orido, they have a band from 910 to 935 megahertz. Divided. Okay, so first user will get this band, second user this one, third user this one, fourth, fifth, and so on. Good. Each user will get a band. And why it was used in 1G? It was easy. Remember that 1G was analog. So how to get a band for a user? How you will get a band from a total? Hamza, how can you get a band, a small band out of the total? You only want to transmit on this band. What you will do? And whatever. Abu Hassan. That's it. You will put a filter, okay? And you all studied filters in electronics, okay? And how to make a filter with a capacitor, or inductor, and so on. So this was the easier, okay, to do a filter. So and here it's as written, it is in 1G. Before I explain advantages and disadvantages, let me explain a bit about 1G. When is the last time that you used the 1G phone? Nokia? What Nokia? 10? That was a 2G. Which one؟ اللي له هيك سلك انسحب تعمل هيك 2G. No, it is 1G. So this is called cellular. I will talk about it today. No. When was the last time you used the 1G phone? Never. This is the point. I guess that you never used the 1G. Here in Qatar, it was not even deployed. So what is the 1G? Maybe I told you about this. So if you watch an old movie from the 80s, the fancy cars, they have a phone in the car. and it has not to be any car. It has to be a luxurious car, okay? BMW 700 series, Mercedes-Benz S series, something like that. Okay, so it has to be an expensive car because the phone, it was very expensive. Okay, and it was a phone that is between the driver and the passenger. Okay, the size of the phone is like this. Like this, but yeah, flipped. So imagine it is this far, but flipped. So this is inside the car, and the phone, you catch it from here. So the phone was really large. Why it was large? It was analog. I will discuss now why it was large. So here, this was the first phone, the 1G. Where it was deployed, first of all? Well, can you make a guess? No. Money wise. Where is the money? Where? Where is the money, Abu Hassan? Banks. So كويس, good. Where are the banks? Where is the high concentration of banks in the world? اوكي انا سبيسيفيك سبوت يعني ما عملوش كل امريكا مره واحده. اوكي جود مور سبيسيفيك. You haven't heard about Wall Street? Okay, good. No? Really?
The newspaper, Wall Street.
Okay, that's difficult. طيب. So there is an area in New York, okay, it's called the Wall Street. So they are the big banks like JP Morgan or this kind of, so we are talking about billions. So the people working there, they ask, can't we have a way to make phone calls, okay? Stock market, this is there, okay, in Wall Street. So to make phone calls while we move with the cars, okay, we really need it. Okay, so they came up and the first network was there. So it's the Manhattan area. So this is Manhattan area. They put here a tower in the middle. Okay, and its coverage was like this. Okay, equipment by, well, first of all, who did it? The network is called AT&T. Have you heard about it? Bell Lab? AT&T? No? Yes? Where? Yeah, so it is an operator like Vodafone or Ooredoo, but yeah, it is one of the oldest in the world. Okay, AT&T, and the equipment, the equipment was by Motorola. Have you heard about Motorola? Okay, good. So Motorola now is people look to it كيخ okay, but yeah, years ago it was the best okay, in the market. So yeah, Motorola was the equipment was by Motorola, and the operator was AT&T. How many users they could fit? If I'm not mistaken, okay, if I properly remember, it was 534 users. Good. You can check the exact number, okay, on internet. So the first number was 534. The equipment was very expensive, $10,000. Okay, at that time was a fortune. Okay, $10,000. Okay, and only 534 customers. The queue was huge. Why? There are more people that they want this kind of devices. Okay, but yeah, they said that this is the frequency band. They divide this frequency band. They had 534. End of the story. It's a cake. They divided the cake into pieces. 534 pieces. Okay, each user has its own piece. Problem. The limited number of customers. Okay, so it's a business. Okay, and in business you need more customers. But yeah, there are no more frequencies. What to do? What can you suggest, ya Shihab? Billah alayk. Yeah, for sure. But we are in 1970s. Okay, in late 70s, beginning of 80s. Yes.
The bandwidth.
The bandwidth is fixed. Frequencies خلاص purchased.
They cannot divide it more because there will be more error.
Mm-hmm. No. Another what?
Another frequency.
خلاص frequencies done. We don't have more frequencies. If you combine different frequencies, you will get less. Solution. Anything? Anyone can recommend something here?
Set a time limit for each user.
Yes. Okay. You can use the phone from 8 o'clock in the morning to 12 in the afternoon. After that, you are not allowed. That will work? No, it will not. I need to increase the number of customers. Okay. By the way, it was a nice engineering exercise. Okay. All the engineers working there, they got crazy, but yeah, they had fun. Or at least this is what they say. Buy another equipment?
By 134.
Again, what?
534, 534.
That's it. So here they said, okay, طب يعني why we have only one base station? Why we have only one tower? Let's have two towers. Well, actually they started with let's have four towers. يعني this is the area. Yeah, don't worry. So the first tower, second one, third one, fourth one. But now we have 534 times 4. So we have more than 2,000 customers. Okay. Now we have more users. This is the idea. Okay. And here they sell that why we have one cell, we have more than one cell. And here this is where the word cellular came from. Okay. It's called cellular communication. Okay. Even in some countries, Arabic countries, they still call the phone, they call it khalawi. Where came this word from? Khaliya. So they made a literal translation. Okay. So yeah, it's called cellular because we have more than one cell. Good. So here, this idea of cellular, it's the base of communication now. Okay. What is the challenge for this cellular? Who said before, Ya Abu Asal? Or someone said something. The interference. So here, the major issue, it will be interference. How? Imagine that. Let me change the color. So customer 499 for this cell, okay, is here. Customer 499 for this cell is here. What will happen? They are very close to each other. Actually, Abu Asal, what are you doing? Okay. So what will happen? They will hear each other. This will hear this one. This will hear this one. They will be happy. Okay, good. So here we will have a large interference. So they found a way. So they put some kind of encryption, okay, on the communication so that they don't hear each other, but they will hear a background noise. But yeah, there was interference. There is a way to deal with the interference. Okay. So this was the first problem that they saw. Second problem, it's called cellular, right? So and it is called mobile system. So in theory, they will give you the phone and you can move. Imagine there is a guy here, the big boss of a company, okay, and he is in the car moving like this. What will happen? So here, in theory, whenever they set up the system, this guy can connect only to this one. Once it reaches this point, the phone call will be dropped because there is no connection, okay, there is no coverage. Then he has to make another phone call. That was convenient? No. Okay, so they said we need a way so the user, whenever he moves from cell to cell, the phone call will continue. Okay, then they came up with a solution. The solution is called handover or handoff. The same word, American, English American or English British. So what is handover as a word? What does it mean? You have something, you give it to the other one. So you, with your hand, you give it to the other one. So this is the handover. So here, what is the story? The story is that this guy will be connected to this base station. Okay, whenever he will reach this point, this base station, it will tell to the user, hey, I cannot give you coverage anymore. So I will make this other base station to cover you. So I will make the user to be handovered to the next base station. Good? Clear the idea of handover? You like it? It's good? What is the problem with handover? There is some delay. So here with the handover, there is some delay. And there is probability of failure. Maybe. Do you see any problem with handover here in Qatar? That's it. Okay, so maybe here, how much we said? 534. Not only that, let's go to 1G before going to Qatar. Okay, so here imagine that what is the number we said? 499. So here this user was using the 499 frequency. Okay, Now here in cell 2, 499 is used by other one. What to do? Officially, we have only here at this point, you only have coverage from this cell. What to do? Do you understand the scenario? Again, this user is using frequency 499. Whenever he is moving to the other cell, in the other cell there is another user for 499. يعني يقول والله sorry والله اجاك ضيف فيعني stop by cannot work. What to do? This is the first option. Okay, so the first option is that this user is 499. Here 499 is busy, but maybe 51 is available. No one is using now 51. Okay, so they will move this user to this frequency. Good. Maybe all of the frequencies are busy. Okay, so the connection is dropped, like here, whenever we have a failure in the handover. Good. Remember that this system is 1G. So whenever you are at 499, you want to make it at 51. What you have to do? Change the filter. Okay. This is why the phone was like this large. The phone, inside the phone, there were 534 filters. Okay, and the filters are analog. How are the filters in analog? Yes, you have. That's it. So they are components. Okay, so the device was that large. Okay, and inside it we have 534 filters, each one at a different frequency, and each one like this in size. Okay, so this is why it was bulky. Good. So whenever then we need the user to switch from 499 to 51, we should say to the receiver, to the user, switch from this frequency to this frequency. Okay, so the phone should automatically, okay, turn off a frequency, turn on another frequency, and this has to be, as your colleague said, very fast. Okay, in analog this was not fast. Okay, so here, where is the first problem? Equipment must switch between the frequencies. Frequency agile, it means that has to be fast. Okay, and the device was not fast. Okay, so here the users, whenever they were moving within the cells, it was disconnecting for 2 or 3 seconds, then connecting again. Now we will never accept that. Okay, but in the 80s it was acceptable. It was the first phone, people, it was new to them. Okay, yeah, it was something better than nothing. Cool, clear. Okay, so handover is challenging. And imagine the user wants to send, when he is making a phone call, he wants to send an SMS. What to do? Yeah. If he stop, but yeah, we don't want to stop. While he is making the phone call, he wants to send an SMS, or an SMS is arriving to him. They want to upgrade the system. They started upgrading the system. Okay, they said, can't we send SMS? Because it was still in mind of the people, this device that beeps. Have you ever seen it? That one, the pager. Okay, so what the pager is, call me at a phone number. This was the usual message. Okay, on the pager. So there was some need, okay, of this kind of messages. Okay, so again, to our problem, the guy was making a phone call and there was a need to send something to that user. Is that possible? The frequency was already busy. Can we use 2 frequencies? No, the system cannot use 2 frequencies. Okay, then was this the second problem. Okay, so here multiple channels, not possible. Okay, but on the other hand, good stuff. The complexity is low compared to any other system. Filter here, filter here, filter here. Okay, it is continuous in time. You will understand it on the next one. And here, your band, no one is using your band. Okay, unless it's in another cell. Cool. Then now the question, why 4? Why not 16 cells? Why 4 cells, not 16? On the need, yeah, definitely there is a lot of need there. There was a queue of people. start so that you get the number, and it was a huge business. Okay, so but yeah, there was a huge queue. Okay, the queue reached 50,000 people paying money, okay, just to reserve a slot. Why not 16? There will be more interference. Yeah. So they have to say, okay, 4, maybe 6, but yeah, whenever needed, they could put more. Okay. Example here, W cell. How many cells do we have there? So many. Okay. So initially they put 1. Then whenever more people were arriving for the World Cup, 1 more. Well, if you need 1 more, okay, they were loading the hand. Even if you went there on the last day of the World Cup, it was full. Yeah, okay. I don't know how many thousand people they were there, and the system was working fine. How? More cells. No, there was no other story. Okay. Clear. Clear.
They are not using 1G.
Definitely. So yeah, more cells. Yeah. Okay. Good so far about this system. Abu Asal, what's your question? Sure. You, sir. I'm good. Let's go to the next one. Before going to the next one, what do you think that was the headache for the engineers here?
Size. And the number is limited.
The number is limited. This is from business. So for business point of view, the number is limited. We need more resources so we can sell more product. Business point. But for engineers, something more. So this is the last analog system. So on the next one, it is digital. So the filters they were not an issue anymore. What do you think that was the headache here? Hani, based on what you have explained, what seems to be the challenging stuff? I said interface, no. No. Guys, we're asking that you have explained. No. No. The headache here for the engineer was this. How to decrease the delay for the handover, how to make it with low probability of failure, how to make it more suitable, and so on. So whenever they design this system, this is the 2G. Okay, here, the GSM. 2G. Okay? So the first thing that for engineers said, please find us a solution for the handover. Okay? And the business people, what they said, yeah. It was 1 week off يعني.
More number of customers.
That's it. So the business people, they said we need more customers, okay, for this business to be better, okay. And the engineer said we need a solution for the handover. Good. Yalla, make the design. They started with design, and they said it has to be digital, okay, cannot be any more analog. So they said, okay, let's divide the time. How to divide the time? The idea is I will talk first, then he will talk next, then he will talk next, then he will talk next. I said, طب what will happen? I will talk, then I will shut up for a while. I will make, hi, how are you? All good. Yeah. This is not logical. They said, what is the solution? Well, first of all, they had to, or they found out something interesting. What is that something interesting? They found out that the ear human auditive system, if there is a disconnection less than 150 milliseconds, humans will not notice. You receive a signal, after 150 milliseconds, you receive another signal, your ear, subhanallah, it will make them to be continuous. Okay, so it will make an automatic interpolation. Okay, so it will connect them together so that you hear them to be continuous. This is, we can benefit from this. From 150 milliseconds to 400 milliseconds, you will notice that there is some noise, okay? after 400 milliseconds, you will notice that, yeah, it is disconnecting. Good, but yeah, so from 0 to 150 milliseconds, you are good. So they said, okay, so can we make a system that is disconnected over time, but less than 150 milliseconds? It will be disconnected, okay, and humans will not realize. So it is perfect. Good. So they said this is 10 milliseconds. We divide it into 8. So here this is user 1, user 2, user 3, user 4, another 10 milliseconds. We can give this one to user 1 again. Disconnected. Okay, so here it is a discontinuous system. Whenever it is discontinuous, before that, do you see any problem with this discontinuous system? I told you that if it is discontinuous, still it is okay. But do you see any issue? Of what? Hamad. Hamad, do you see any problem? Abu Asad. The phone is actually doing this, so it is now if you take your phone to the lab and you see the signal that is going from the phone, it is signal, shut up, signal, and so on. So it is continuously turning on and off all the time. Okay, not the phone and the screen on and off, yeah, but the signal that is sent, okay, is sent, then stopping, sent, stopping. Okay, but yeah, it is digital, so it is simply on off, so it's fine. If it was going to be implemented in analog, it was simply impossible. Okay, but because it is in digital, doable. But yeah, where is the problem here? You don't see it? Of what? The 150 milliseconds, it's a delay, but it is a perfect delay. You will feel it as 0.
We need more power to do that.
Why?
For the phone. For the phone.
Abu Asad. You raised the hand, right? Amir. Synchronization, it is a problem that has been solved. But no, there is a bigger problem based on what I have explained so far. والله ما حكيت distance.
Switch between channel from tower to other tower.
ممكن تعيد بس مرة ثانية.
Yeah. How many users can access now based on what I have explained? Based on what I have explained, how many users can access?
No, less. 10 milliseconds, 5 users.
8, I said. So here, each 10 milliseconds, I divided in 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good point. Okay, so here, what your colleague said. So here, these are 10 milliseconds. 8. Then here, the other 10 milliseconds. 8, and so on. Okay, and this user that is allocated here, maximum it can wait up to 150 milliseconds. So here at the first one of 100 milliseconds, okay, it has to be allocated again, right? So how many users they can fit? The 8 here multiplying how many 10 milliseconds in 150 milliseconds? 15. How 100 and how much? 40? 120, yes. 120 users, right? Is this a good number? Even it is less than 534. Do you like it? Yeah, يعني business after all يعني a system that the nicest system in the world, okay, if it is not commercial, it is useless. And the best engineer in the world is the engineer that he is aware also of the money. So what they have done, okay, they said, okay, this is the 120 users that they can support. Then this system cannot be used alone. We cannot use TDMA alone. By the way, maybe I have to say here. So FD, okay, the official name is called FDMA, frequency division multiple access. Okay, and TDMA, time division multiple access. So they said TDMA cannot be used alone. It has to be combined with FDMA. How? They said that this is the frequency band. Okay, and in each frequency band, so here this is the frequency. And in each frequency band, we will use the time division. Okay, so here this is frequency from 910 to 911, from 911 to 912. So this is in megahertz. Okay, and now this is time in seconds or in milliseconds. Now then here we divide it like this. So here we take all of this and we put it here. So it will be 10 milliseconds, 20 milliseconds, up to 150 milliseconds. Good. So the system is TDMA, FDMA. Good. It is a combined. For the same band, how many frequencies? So here in the system is 35, 200 each, 175. Yeah, this is one. So the system has 160 frequencies. Okay, the system has 160 frequency bands. Each band supports 100, so we have 160 multiplying 120. This is now the number of users that can be supported in one cell. It is large. Yeah, very large. Okay, so this is the total number that can be supported in the system. Okay, and the users will not notice that they have been discontinuous in time. Okay, and the system will work perfectly. Good. Actually, this system is the best for phone calls. Even now, okay, here in Qatar we have 5G. Whenever you are connected to 5G and you receive a phone call, what happens to your 5G? Have you ever seen that on the screen? What happens?
Drop to 3G.
Yeah, it's dropped to 3G or to E, to 2G. So whenever you are connected here on your mobile phone, okay, to whatever is the network, 5G or 4G, if you receive a phone call, it will be immediately moved to 2G or 3G. Why? Because it is really doing well. Okay, so 2G is the best in terms of phone calls. Good. Okay. This is from business point of view. Let's go now for engineering point of view. There is here, let's see how we can make a handover. So cell 1, cell 2, there is a user that is moving like this. Okay. Now this user wants to disconnect from cell 1 and to connect to cell 2. Why this system has an advantage? Notice that the user by default is discontinuous. So he will send this one on cell 1, and then he has 150 milliseconds to do the change to cell 2. Okay, so the system will make the change, it will double check that it is correct, it will triple check it is all correct. Then after 150 milliseconds, now this packet now is for the user again, it will be received from cell 2. Let me repeat, because the system is discontinuous. So what we will do is that we will take benefit of all this time that is discontinuous to make the engineering. okay, to check that how to do the handover, to it is correctly done, or to double check or triple check it is all okay. Oh, okay, all good. Then move on. Good. So here we will have more time. Even here there is a mistake. Then on the handover, we can do it again, or again and again. So we have a lot of time, okay, in order to do properly the handover. This is why with this approach, the probability of successful handover has increased a lot. Again, why? Because there is a lot of time, okay, that is on idle, okay, to check that everything is working fine. So this way, it solves the problem for, well, the headache for engineers. But what we learned from engineering, Yashab, once you solve a problem, another one will come. And this is the best for engineers. Why it is the best for engineers, Yashab? That's it. They always need you. Because the problem will never finish. Then handover was done. So where is it? Handover is easier. Okay, as I wrote here, due to the discontinuity. Good. What else? The frequency agility is not a problem anymore. Okay, why? The system is actually digital. Okay, and the system, because it is digital and discontinuous, actually, okay, you can be given as a user your time slot here, then the next time slot here, 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 and so on. Okay, the system is digital. Turn off the filter here, turn on the filter here, turn off the filter here, turn on the filter here, and so on. Okay, so it is programmed much easier. So here the frequency is fine, and we can have more than one time slot. And here, well, I need more to send an SMS while I'm making a phone call. So we will give 2 time slots for the user. Actually, we have a lot. How much we have? We have all of this. But if you give 2 to one user, that's fine. Not only that, they can even give internet access to the user. How they will give internet access? They want internet access here on the 2G. Even now on your phone, if you have the E instead of 3G or 4G, if you have the E, it means that you are connected over 2G to the internet. What is the characteristic? Do you like it? Whenever it connects to E, very slow, but yeah, at least there is something. Okay, you can send a WhatsApp, or you can turn on I don't know. Well, you can open Google, videos or images, nothing. Okay, but something good, low data rate. How to do it here on 2G? They will give you all the 8 of them. All the 8 are given to you. Well, if there are no more users, okay, if there are other users that they want to access, they will give you 4 or 2 or simply 1. If they will give you 1, very low data rate. By the way, the data rate here, data rate in each slot. How many megabits do you think it will be? Kilobits. How many? 3. Okay, so it is 16 kilobits per second. Okay, so how much is then the maximum data rate that you can get, okay, on 2G, ya Hamad? That's it. So here you can get a maximum of 8. So 16 multiplying 8. How much is it? 256? 56? Guys, كلكم فاهمين؟ 128 kilobit per second. No more. But this is the maximum data rate that you can get whenever you connect to 2G. So whenever you are connected with this E, this is the maximum data rate that you can get. No, it's impossible to get more. But yeah, compared to 1G, this was yani wow. Good? Clear? All of these are the good stuff. Let's go to the bad stuff. Synchronization is required. Okay. What is the issue with synchronization? What is synchronization? Okay, different time. So whenever we need the system to be synchronized, so all the systems should be with the same time. And here it's very important because 10 milliseconds, so this will be from 0 to 10/8 milliseconds and so on. So here our time has to be very strict when you have on, when you are off, right? How to guarantee this? The only way to guarantee this is that to make all the cells, because here maybe if you go from one cell to the other cell, if the clock for this one is different than the clock for this one, you destroyed the synchronization, okay? So in order for this system to work, they need that all the cells to be connected to the same clock. How can we connect all the cells to the same clock? A wire works, but maybe as we said here, they are not connected on with the wire. So how can you make all of them to connect to the same clock?
From the beginning, before when we're gonna manufacture it.
Yeah, but we know even digital clocks, okay, digital watches, okay, that there will be some drift from time to time.
Send another signal from time to time.
But you need a reference, and you need a reference to be the same for all.
Connect to the internet. They have like time there. So all of them they check the time there.
Good exercise. Okay, it was not done because maybe the base station will lose internet connection. So if it loses internet connection, we need at least the guys to make phone call between them. Okay. Second one, whenever they started this standard, that was not an option. How to have then the same clock for all the base stations?
You have to gather them at the beginning, and then you have to separate them.
Yeah, but even now, okay, we deploy in Lusail, then we will deploy in Al Khor, then so it's always expansion. We don't go and we cover all Qatar at the same time. So imagine the US. حذيفة. No. By the way, I'm out attendance. Sorry. رمضان ما فيه. We have only 13 out of 38. متين؟ صح عشان اطلع بكير. Thanks. Sorry. شو بتحكي about it? So how to make them then all synchronized? The only way is through satellite. So this is why even now here we have every base station is connected to GPS. You know what is GPS? You know what you don't know what is GPS? That's it. So the GPS is used for location. Here, do we need to know the location of the base station? No, it's not moving. Fixed my here base station. Okay. So why we need them to connect to the GPS? So all of them they connect to the same GPS. So this way we guarantee that all of them they have the same clock, even if it is shifted. But all of them shifted, it works. Okay. Problem with GPS. Now that you have a story about GPS. Who owns GPS? Google. لا. Who owns GPS? The GPS as a network يعني. Who is the owner for the GPS? GPS are 29 satellites. Who owns the GPS? You never ask yourself this question? What is the key word in engineering, Hisham? Curiosity. Okay, good. You have internet, right? You all have internet? And you can make search. Who owns the GPS? We close. Okay. It is owned by the US military, not the US government. Okay, take your stuff and leave. Okay. So so it is owned by the military, not by the government. Okay. So what is the problem with that, Hisham? You have to leave. Hisham, right? Yes, you have to leave. So what is the problem with the military? Even now, whenever you buy the phone, it is written there, okay, that this system is owned by the US military. It could be used for other purposes, okay? What happened in 2003? You like history? ولا أنا بس 2003. Do you know what happened in 2003? No, something important. What? Yeah, what he said? What happened in 2003? برجين. لا يا. No. 2003 Iraq was invaded, okay? Whenever it was invaded, okay, they noticed that in Europe that the communication was not going well at all. So the quality for the connection was dropping. Handover probability of success was dropping. They said, what's happening? What's going on? Okay? So what's going on is that the US military, they moved their satellites to be on top of Iraq so that they notice what's happening, they move their troops and so on. But what happened to the rest of the world? Much less satellites. Okay, so they realized in Europe whenever they started, they started digging what's happening. Okay, what happened with our network? Okay, so they realized that many of the base stations, they don't have coverage. They don't connect to the GPS. Okay, so the time drifts. Then we have dropping of the calls and so on. They complained. What they answered them? No, they answered them something else. قال لهم هي الطوف. Good. This is owned by the US military, okay? And its main purpose is for the US military. We try to help you with the GPS or Google Maps or all the stuff, but yeah, it is mainly for US military. Okay, we need it now. Sorry. Okay, this is why then they started their own system. Do you know what is the own system for the European people? You study electrical engineers? So, okay, طيب. So, the GPS, okay, there is another one, it's called Galileo. Okay, the Galileo system for the European, okay? Well, then the Russian did the same. It's called the GLONASS, okay, system. And then the Chinese did the same. لا ده يشوى. Okay. Then they have the Baidu. Japanese another one. Okay. And every country they got scared. يعني we need our own. طب here in Qatar. Sorry.
مصر عندهم واحد ولا؟
ويز مين تبع فين؟
Sorry. ويز. شو معنى ويز؟
نفس الابلكيشن نفس الجهاز. ويز يقولون اسرائيلي.
The Waze is purely Israeli application, okay, owned by Google, but still developed in Tel Aviv. Okay, so but yeah, it is using anyone. So your phone now, whenever it connects, it's not GPS anymore. All people say GPS, but the phone is able to connect to any one of them. Okay, so all of them, they are doable to be used. So here in Qatar we use any combination. Okay, so not needed for that. But even of that, here in Qatar we have our own satellite. You know what? So a SailSat also can be used to give synchronization to the network. Good? This way, we guarantee that the system is synchronized. Cool? Clear? Questions?
يعني ساعات بس يعني بس coverage
No. Okay. يعني Ishel-Sat, they have two satellites. يعني between Ishel-Sat 1 and 2, they cover Middle East, North Africa, Iran. With Ishel-Sat 2, they reach to India or Pakistan. Why they don't have more? There is no business model. We asked the same question to them. Why you don't have more? I said, no need so far. Okay. There are plans for Ishel-Sat 3, but with the two of them, they are for now and for their business model or for their customers is more than enough. Cool. Questions? Yeah. We stop then so that you can reach your exam. Okay. We stop here and see you on Wednesday, inshallah. أهلا وسهلا.